Today we're going to be converting polar equations into rectangular form, and I want to start out with the three examples that I had from last night's video. Theta equals pi over 4, r equals 3, and r is equal to 2 times the cosine of theta. So there are really four things that we have to remember when we're converting from polar form into rectangular form. The four things to remember or to keep in mind, because what we have to do is we want to turn anything with r or theta into x and y. So four things to keep in mind when converting from polar, which is r theta, to rectangular, which is xy. So all the r theta should go away, and the only things we should have left are x and y and some numbers. Four things we need to remember is that, first of all, r cosine of theta is equal to x. And I think we learned that earlier a couple of days ago in the video before. Yeah, I can show you on 2 days ago video. X is equal to r cosine theta and y is equal to r sine of theta. You should have that in your notes a couple pages back. So we're going to keep that in mind when we're converting. The second thing is that r sine of theta is going to always convert into a y. Third thing is that r squared is equal to x squared plus y squared. These are just the replacements that we're going to be making whenever we encounter them. And the fourth thing is that the tangent of theta is equal to y over x, and that's on the previous page. If you remember over here, r squared, whoops, you can't see it. R is equal to the square root of x squared plus y squared, but when you square both sides, you get r squared is equal to x squared plus y squared. And I'm going to turn the tangent of theta into inverse tangent of theta, so we can use that and convert easily. So, in other words, the inverse tangent of y over x is equal to theta. So with those four things in mind, we're going to take these equations. First of all, we have a theta in here. We don't have any r's, so we're not going to look at those first three things. But what we're going to do is we're going to change theta into inverse tan of y over x. I'm sorry. So the inverse tan of, whoops, I wrote this wrong. The inverse tan of y over x is equal to pi over 4. Well, the inverse tan of y over x is equal to pi over 4. Well, this is the same thing as saying the tangent of pi over 4 is equal to y over x. That's what inverse tan means. So tangent of pi over 4 is equal to y over x, and the tangent of pi over 4 is equal to 1. So 1 is equal to y over x, and if you multiply both sides by x, you get the rectangular equation y is equal to x. And if you look at the graph that we graphed on yesterday's video, you can see that this, if we put this on rectangular coordinates, that you could see that this would be the graph of y equals x. The second example is r is equal to 3. Well, we don't have any direct replacements with just plain old r, but if we square both sides, we will get r squared equals 3 squared, or in other words, r squared is equal to 9. And we can replace r squared with x squared plus y squared. And this is our rectangular equation for the second graph that we did, because x squared plus y squared equals 9 is the equation, the rectangular equation of a circle whose center is at 0, 0, and whose radius is the square root of 9, or 3. And that's what we graphed yesterday on our polar paper. If this were in rectangular coordinates, this would be x squared plus y squared is equal to 3. But in polar coordinates, in a polar equation, this equation is r equals 3. The last example that we have is r is equal to 2 cosine of theta. Well, we don't have anything that's just plain old cosine of theta. We have an r cosine of theta that we can replace. So what we can do in example 3 is we're going to multiply both sides by r. Instead of squaring both sides, because squaring both sides could get rid of the r and make it r squared, and then we can do the replacement like we did, but it wouldn't get rid of this if you squared the right hand side. So we are going to use this mathemagic by multiplying both sides by r. So if you multiply the left hand side by r times r is r squared, and if you multiply the right hand side by r, you get 2 times r times cosine theta, which is 2r cosine of theta. And now we have these two items that we can directly replace. R squared is replaced with x squared plus y squared. I think I'll come over here on this side. So going over here, r squared gets replaced with x squared plus y squared. And 2r cosine theta, well, 2 stays a 2, but r cosine theta turns into an x. And now we've gotten rid of the r and the theta, and we have this in rectangular form. But this isn't standard form of that circle that we graphed yesterday. What we have to do is subtract 2x from each side, x squared minus 2x, and if you remember from Algebra 2, converting from standard form into center radius form, we have to do a complete the square. So I'm going to put plus blank plus y squared, this is that y squared, is equal to, well, when we took the 2x away, on the right hand side we're left with a 0, but we're going to add half of b squared. Half of negative 2 squared is 1, so we're going to add 1 to both sides. And now with the complete the square, this part of it can be factored into x minus 1 squared plus y squared is equal to 1. This is the equation of a circle in center radius form, and we know that the center of this circle is at 1, 0, and the radius is the square root of 1, which is just 1. So here's the rectangular equation. For this polar equation, r equals 2 cosine of theta. And here's the graph that we created yesterday. I think I mentioned that the center of this was at 1, 0 in rectangular form, which is actually, it's right there. And you can see that this circle has a radius of 1, center and radius. Now what I'm going to do is I'm going to show you on the graphing calculator, and I think we've all been anxious to find out how we can graph polar equations in the graphing calculator, or you've probably figured it out by now. What we're going to do is press the mode button, and down on the fourth line down, instead of function mode, you're going to turn it into POL, which is polar mode. Make sure your third line down is your calculator is in radians mode. And what we're going to do is press y equals, and now you can see that in polar form all of these equations are solved for r. So if we want to graph the first equation that we were given, theta is equal to pi over 4, there's really not a way that you can get that into r equals. So we'll go down to the second equation, r equals 3. And if you wanted to graph that, just press the graph button. And there's our circle with the radius of 3. I think my window probably want to step on the x-axis. Yeah, I want to step, or I want to make the scale on my x-axis equal to 1. And I also want to make the scale on my y-axis equal to 1, so that's okay. So now here we go. Here's the radius of 3, the circle. If we want to create a bunch of circles, if we want to create a circle with a radius of 1, we can press 1, radius equal to 2, radius equal to 4, so we can actually get 4 circles of all those different radii, and you can see them all graphed one at a time. So it kind of looks like a bullseye. The next equation that we graphed equation number 3, which was a circle and the center was at 1, 0. That was 2 cosine of theta, I believe. R equals 2 cosine of theta. So when you press the graph button, you're going to get a small circle. The radius is equal to 1, and the center is at 1, 0. I want to show you a couple of other things that are just quick changes on this. If you wanted to change cosine into sine, you're going to get a very similar graph. The only difference is the center is going to be at 0, 1 instead of 1, 0, because when we convert this from polar to rectangular form, we will get r sine of theta being converted into a y. So we'll have to go through the same complete the square process, but this time the y will, what we had for x, we will have had for y, and you can see that we would have had a circle with the center at 0, 1 instead of 1, 0. And if you want to have the center at other places, if you wanted to make the 2 negative, if you wanted to have r equal negative 2 sine of theta, that circle would be, the center would be at 0, negative 1. And you can probably guess how to make the center of that circle into negative 1, 0. Take the original equation we had, 2 cosine of theta, and just make it negative 2 cosine of theta. So there you have it. And if you wanted to change the 2 into a 4, you can see the center is at negative 2, 0 instead of negative 1, 0. So you're actually going to take half of that and square it, half of this value and square it, and that's how you would get the center of that circle. Now we're going to look at example number 4 of an equation in polar form. We're going to look at this example. R is equal to 3 times a cosecant of theta. Well, cosecant isn't on our list of 4 things that we have to remember, but if you remember the cosecant is the reciprocal of the sine, what you're going to do is you're going to replace cosecant with 1 over sine. Whoops, you can't even see what I'm doing. Sorry. There you go. So r is equal to 3 cosecant of theta. And whenever you see a cosecant or a secant, you're going to convert that into sine or cosine, whatever it is. This is the reciprocal of the sine. So 3 cosecant of theta, that would actually be r is equal to 3 over the sine of theta, because a cosecant turns into 1 over sine. So this equation turns into 3 over sine of theta. So what that means is we're going to multiply both sides by sine of theta to get rid of the denominator, and you're going to get r sine of theta is equal to 3. Well, we could set up our r theta table of values if we wanted to, but it would take a lot less time if we convert this from a polar equation to rectangular equation. It would be much faster to graph it that way. So let's convert to rectangular. If you remember, r sine of theta is equal to y. So this equation is just y is equal to 3. And if you wanted to graph y is equal to 3 on polar paper, you would take the polar paper and you'd just go up to the 3rd ring, 1, 2, 3, and you'd plot a point like this. And then all you'd have to do is take a straight edge, which I don't have my badge on me, so I'll just use my phone as a straight edge. So it would look like this. This is y equals 3, but in polar form, this is r equals 3 cosecant of theta. So that's how you can graph a horizontal line. Let's look at example 5. R is equal to 4 secant of theta. Well, the secant of theta is the reciprocal of the cosine, so this is going to turn into r is equal to 4 over the cosine of theta. And when you cross multiply, you'll get r cosine of theta is equal to 4, and r cosine of theta will always get replaced with just an x. So x equals 4 would be the rectangular equation of 4 secant of theta. And if you wanted to graph x equals 4 on polar paper, you'd go over to the 1, 2, 3, you'd go over to the 4th ring, take your straight edge out, whatever that may be. And this is x equals 4 in rectangular, but in polar coordinates, this is r is equal to 4 secant of theta. And you can imagine if you wanted to draw a vertical line on the left-hand side of this axis, you would just negate this. Or if you wanted to draw a horizontal line underneath this polar axis, then you would just negate that. So let's just take a look at the graphing calculator and how we would put that in. Press y equals, clear out the old stuff. 3 cosecant of theta is 3 divided by sine of theta. And let's put the other one in. Let's put 4 divided by cosine of theta to get both of those lines in at the same time. So when we graph this, here is our perfectly vertical line. Here's our perfectly horizontal line. And if we wanted to have a diagonal line, that would be theta equals pi over 6 or theta equals pi over 4, or whatever the angle is. And then our last example of the day, example 6. This one is going to look a little crazy, but it really isn't that bad. Let's say we want to graph y equals 2 over 4 cosine of theta minus 3 sine of theta. Well, we could plop that right into our graphing calculator if we wanted to and see what it looked like. But let's say we don't have a graphing calculator, we just want to know what the shape of this graph is. Well, we're going to cross multiply, because what I can see is we're going to get a 4 times r cosine of theta and 3 times r sine of theta, which is replaceable with one of those 4 items. So let's cross multiply. We have r times this entire denominator, so I'm going to put the 4 outside and 4r cosine of theta. And then we're going to have minus 3 times r sine of theta is equal to 2. Replacing r cosine of theta with x, we get 4x minus 3y, because our sine of theta is equal to y, is equal to 2. Well, that's just a straight line. That's in standard format. And if you wanted to solve this for y, you could subtract, actually I would add 3y to both sides, 4x, and then subtract 2. 4x minus 2 is equal to 3y, and divide everything through by 3, and then you get y equals 4/3 x minus 2/3. So this would be how you could create a diagonal line using polar coordinates. The slope would be the coefficient of the cosine divided by the negative coefficient of the sine. The y-intercept would be the numerator divided by the coefficient of the sine. So let's put that into our calculator. We'll clear out those last 2. And if you don't use your alpha y equals, you're going to have to surround that denominator with parentheses, but I like the alpha y equals so I don't have to put parentheses in. So we have 2 over 4 cosine of theta minus 3 sine of theta. And then when we press the graph button, we'll see we'll get a diagonal line, and this slope is 4/3 and the y-intercept is -2/3. It's only part of that line though, because of what I believe if we set our window, let's see if this works. It's set at 2 pi now. If we set it to 4 pi, let's see if that's going to make a difference. I'm not sure. That's just a segment of that line. So that's how to convert polar equations into rectangular equations. Just make sure you can do all of those replacements from the four things to keep in mind.